Okay. Um, there are two ways of going about the research process, and one is a very common but faulty way, and the other one is probably less common but a much better approach. The first one, which we can see in the top line here, is that you already have a preformed conclusion. You have something that you is an opinion, and you want to find reasons why this opinion is correct. So you find these arguments or reasons, and then you want to find scientific evidence that supports your claims. Um, this is a very common approach, but it is very, very problematic. You could even call it unscientific. The reason for that is that the conclusion you already have, if you already know what you're thinking about the topic, when you look for reasons and then for evidence supporting those reasons, you will only look for reasons which support your claim. And if you will find or encounter arguments or evidence that speaks against your idea, you'll very likely either disregard that evidence or even perhaps not see it in the first place. So you will be blind to information that is contrary to your own beliefs. This is called the confirmation bias, and it's a way that a human being, how we think, and it's very hard to get away from. So instead, we need to work our way around it using a different process. Um, the correct way of doing things is to look up studies about a topic that interests you, sum up the findings from those articles or studies, and then you draw your conclusion based on that. It's really the same in that you have arguments and studies and conclusions. It's just that this is the order where you're not really that subjected to confirmation bias. So if you do it this way, the conclusions that you draw will be much more aligned to what the studies actually say. For this to work, we of course need to know where to find studies, and we are going to use Google Scholar. Google Scholar is, like Google, a database of information, but in Google Scholar, they've only actually selected the more scientific stuff. So it's articles that can be categorized like in a library style order. So you have a title, you have the author, you have the publication, you have the year of publication, and the website where you can find the text. It's not perfect. All of the information on Google Scholar is not going to be true, but it's a huge improvement as compared to ordinary Google searches. If you search for something, I've searched for confirmation bias here because it's the thing we're talking about, you will notice that the title is clickable. We'll not do that now, but you will come to some sort of database if you click it. You will see that underneath the excerpt here, you'll find a star. The star is a way for you to save this article, or information about the article, I should say, to something called your library. Your library is just a collection of saved texts. You'll actually not be able to save the PDF this way. It's just the information of the title, publication, author, year, etc. Next to the star, well, it's a very good approach, I should say, to use this star, because if you're searching for information, you might want to work quickly, looking through the list, just scanning it through, star marking the ones you think you might want to use, look at later, and that's a very quick way of finding information. Next to the star, you will find these quotation marks, and if you click them, you will see this. This is one of the most practical uses of Google Scholar. It is a tool that gives you footnotes or endnotes. A footnote or an endnote is, of course, a way for you to give information so that other people can find the same text that you have been reading. And they come in various styles. In this, we have 3 different styles available, the MLA, APA, and this one. It doesn't really matter too much which one you use. I would suggest, as we are using, we're talking about psychology here and sociology, the APA one, because that's the one that psychologists would use. But it really doesn't matter much which one you use, as long as you use the same one all the time. So don't mix and match these ones. You need to use one and stick with it. There's really no use of writing your own footnotes, by the way, because even if you have a text that you haven't found on Google Scholar, you can just search for its title in Google Scholar and you will get this sort of box where you can just copy and paste the footnote. Next to the quotation mark, you have something that ends with a number. This is the number of times this article has been quoted. It's a useful number because if you compare two articles, such as the first two ones here, you will see that the first one, even though it's much more recent, 1998, as opposed to 1977, you will see that this one has been quoted many, many more times. What that means is that more people have read this text and more people have found it useful to include in their own writing. That's not a mark of quality in and by itself, but it's a hint that this text is more popular, more widely used in the field by other experts. And if the experts are choosing this one, you might actually do that as well. In some cases, if you're searching for something that is quite niche, this number will be very low. If you scan the page here, you can see that the common number for this type of article is more in the low hundreds. You can even have single digits or no quotations. Should this concern you? Well, yes, if you're choosing between different texts that seem to be of similar quality and one has been widely read and the other one has not, go with the one that the experts prefer. But there are other issues, of course, such as when it's published. If the text is very, very recent, it could be of very high quality, but no one has gone around to using it themselves in their own writing. So you can't just stay yourself blind on this number, but it's a good starting point. Related articles is just what it sounds like. Other articles that are usually quoted by the people who are using this one, and that will give you a lot of important texts, especially ones with high numbers. As you can see, this one has been quoted 42,000 times, which is a very high number indeed. And next to that, you will find versions. This is only useful if you want to read the PDF. The PDF link here is not the same link as this one. So if you want to read the entire text, you go here. If you go here, you can probably not find it for free, but if you go to this link, you can. If this link is broken, you can click that button and you will find that this article has been published on a lot of other sites where you can download the PDF itself. That's basically it. When you know what you're searching for and you want to limit your searches, you can use filters, especially when it comes to year of publication. And of course, you might want to look at more recent stuff if you're researching a field where the more recent stuff is probably better. But in this case, you would probably want to start without filters, because then you will see, have a better overview of the research itself. When it comes to reading these articles, there is a good way and a bad way of doing it. And the good way will save you a lot of time and energy. If we pick one of these, this one for instance, click the PDF link instead of clicking the header link there. Click the PDF link, I will end up with a PDF of this document. All articles of this kind are structured in a similar way, in that they begin with a short abstract, which is typically much less than half a page. It's very short. And then you have an introduction, and then a description of what has been done, the more technical stuff. Here you will see it's a lot of numbers and algorithms and things like that. And then at the very end of the document, you will find some sort of discussion, typically called general discussion. And then after that, you have the references. So a text such as the one we're using here, which is 5 pages, is actually not 5 pages of text. It's a lot of the space is used for other kind of information. The preferred way of reading these is maybe on the surface a bit illogical, but it's actually very, very useful. What you would start doing is read the abstract. The abstract is an executive summary of all the information in the text, all the important information. So if you read the abstract, you have a fairly good idea of what's in the rest of the text. After having read the abstracts, you know probably if it's worthwhile reading more or if you can skip this text and maybe it's not really related to what you want to do or it doesn't seem interesting for the topic that you're studying. But if the abstract gives you information that seems important, you can then move on to reading the introduction. The introduction is a bit more light-hearted than the rest of the text. It's written in a more sometimes more poetic, certainly more enjoyable language. It's not very long, it's typically about half a page. And it gives you a background to why this is a problem, if there's a problem that is being discussed, what people have been thinking about this problem in the past. It gives you a very good idea of this topic that you're studying. After having read that part, you don't go to the next paragraph. In fact, you scroll to the very end of the document. Just before the references, you will find something along the lines of this general discussion here. It might be called different things. In this case, it's a general discussion, but it's the last paragraphs. It's the last heading of the document. That'll give you a summary of what they have been talking about in the text itself. It's a summary of for instance, the methods used. Which means that you don't need to read the rest. You can just read this summary and get an idea of what the findings were. It's sort of like a longer way of giving the information that was given in the abstract. So reading just this part, it's a few paragraphs, just short of half a page, is actually going to give you enough information so that you can consider yourself done with this text. So all the things that's in between is more or less useless, depending a bit on what you want to do. The descriptions of the methods, for instance, is only for other scientists who want maybe to replicate this process. It's not for lay people. It's not for you as a reader if you are not a scientist yourself. So you can skip it. If you would read it, you would probably see that much of it is very hard to understand and, in fact, impossible to understand in some cases, such as various kinds of algorithms and formulas that they might have used. It's not really interesting at all, in fact, because it's just there for other scientists. It's an important part of the scientific process, but it's not an important thing to read for you. So that means reading the abstract, the introduction, and then the general discussion is, in most cases, the parts you need to read, and the rest you can skip. It sounds like cheating, but in fact, this is a deliberate way that these documents are structured, all of them structured in almost identical ways, so that the reader can understand what parts need to be read and what parts can easily be skipped without losing too much information. Because if you are writing about something, you might want to use many of these articles. One article doesn't really say much at all, but if you're using 20, 30, 40, 50 articles, it's going to give you a much better picture. The problem, of course, of reading 50 articles is that that might be too much text. But if you're just reading 10% of 50 articles, it's really like you've been reading 5 full articles. So doing it this way will save you a lot of time, which means that you can spend more time reading more text, which is usually a much better and more effective way of using your own time.